Okay, so I take it we're ready to go on to the second exercise? Okay, ladies and gentlemen, I'd like you to create a time plot. I actually already created a time plot, and so, yes. Oh, okay. Okay, well, some people can start. Yes. Bahar. Oh, yeah. Yes. So, yeah. So, yeah, I actually, Bahare is asking a deep question because I'm actually at a deep statistical level. I'm a little bit unsettled by my clipping. Okay. The reason I'm unsettled by my clipping argument is that, okay, suppose this agent picks a target point to go to. They pick, so they're here, and they pick a target point to go to that's down here. Okay. Right now, we clip this, right? Right now, they were scheduled to go to this target point. We clip it. Where will we actually, where will we actually send them? And, okay, we'll send them to the edge to be sure. Y will never be less than 0, right? So that's good. So Y is going to be 0. But where will X be? It'll actually be here because the X value that was picked. So we're going to be actually sending them in a different direction. And that may induce weird statistics on the sort of the angles at which we. And so I think actually it would be better to clip them at a point like that was along that line. Yeah.
I actually think that clipping's not a great idea.
Yeah.
And the reason for that is because it will push everybody towards the outside, more likely than the inside.
Yeah.
That means now they're on the outside. Every time that they choose to go farther out, they just stay on the outside. So the way that I did it the first time is I just had a little loop, a while loop that basically said
regenerated.
Keep choosing until you're inside the.
Okay, this is great. It's resampling. It's called resampling in computational statistics, and that actually would be somewhat cleaner, Kurt. So, okay, so those are deep comments.
I don't know if you can see. So it's
Right.
preferring the edge.
Right. So Kurt has shown a pathology that arises from clipping, and he's suggesting that perhaps it's not an image that would warm a physicist's heart. It looks like this is what it looks like here. So you'll notice we speed this up, and he points out that there's an unseemly number of agents that are clustering right along this boundary. It's almost like they're searching for ways to leave it.
Yeah. Let me out of here, getting infected.
Right. So the clipping is probably conceptually it's conceptually not the best way to do it. I think Kurt's idea of resampling is actually a great one. And ladies and gentlemen, this brings up another point. Yes, Bahrain.
I would bring the same thing, but using a loop, you can just reflect that point outside, get inside the area, instead of going to the boundary and then
Yes.
they try to go outside, they stay on the boundary, they come in the center of the space.
Right. Right. I think that's an interesting idea. So that would also be a possibility. So maybe what I'll do here is so I will go create a function here as I want, which will be called move to, select and move to new location, something like that, right? And the code for that will actually be initially this code. But I think this idea is a good one. So we could do something like this. So double X, double Y. I don't think it will. It's an interesting question in Java. Will it will allow this? We actually don't need to clip then, is what Kurt is saying. And this, I think, actually Bahare's way would be less expensive to do, right? Yeah. Oh, someone's trying to get in, so if you could let them in. There may be other people trying to get out, but okay. So here I'm going to modify this. I think Bahare's way is a little bit more elegant, and her way would basically involve reflection. So while xdest while is yeah. So while xdest, I could create a function called is in limits. Sure. Is in limits, and it needs to go. So xdest, is it within the limit 0, and that that limit this dot get main dot environment dot get width, and is it within the limits of this of the y. Okay, but this is I think we're getting a little bit bogged down, so I want to move us on quickly here. While it's within these limits, go okay. So we're doing this loop while it's not in the limit. Sorry, it's not in these limits. While it's not in the first limit, or it's not in the second limit, we're going to pick a new one. And once it's finished, we'll do it. Hey, oh man. There we go. And once it's done, we'll move to, okay, yeah, no, that's not going to work. We need to declare these outside here so we could see them after. Sorry, folks. There we go. Okay, good. So I think this is cleaner. And is in limits needs to then be defined. So is in limits, and actually we can actually copy this guy because it's actually has many of the same features. So we're going to copy it, and then we'll go and modify it. So clip to limits. This is now going to return if value to clip, return value to clip is greater than or equal to minimum value, and value to clip is less than or equal to maximum. Okay. Maximum legal. Okay. So we're going to return that if it lies within these limits, and this is going to call is in limits, and this thing is no longer, it's just called value, and so we're just going to do that. Okay, so in short, what I've done is Kurt's solution. It's the solution from the mind of a physicist, which is here. We're going to loop through. This is resampling, a technique used in statistical physics, actually, with Markov chain Monte Carlo algorithms. So here we're, yes?
Why are you using or instead of and?
Because if it's either not in the first limits or if it's not in the second limits, then we're going to resample. We're going to we treat them as a pair. So we resample both. We resample if one is legal, if the x is legal but the y is illegal, we throw it out nonetheless, and we sample again. Okay. There's oh, okay, that's interesting. Oh, of course, is in limits needs to be return what? What does it return? It's a Boolean, right? It's a Boolean. Okay. And it's unhappy camper here. Okay, so what's unhappy about it? Oh, that's interesting. Insert to complete do statement. Oh, I need an extra. Oh, that's why. Yeah, there's a. I think there's actually just an extra one there. Okay. No, insert to complete do statement. Okay. So this guy matches up. Yes, I need another one. Okay. Okay. So there we go. So now, ladies and gentlemen, if we were to examine this situation, I think we would find a more altogether less pathological. Oops. Oh, well, that looks pretty pathological. So here, folks, we remove this. We have to call now select and move to new location. Okay. Okay. So what's going on here? We took this code out of here, and in fact, I think in a nod to Farhad, because I actually agree conceptually, really it's occurring when you first come in, and it's occurring when you arrive. Then we could call either one. And select to and move to location, to new location. It selects a candidate location. So really this should be called X candidate, is really what it should be called, and Y candidate, because they're not actually necessarily the destinations. And this should be X candidate and Y candidate. And so if we select a candidate, and we've got to name them up here too. We select a candidate, and we see if the candidate is legal. In other words, it's only legal as long as it lies within the limits of the first one and the limits of the second one, right? We will cease this as soon as it lies in the limits for both. Maybe just in light of the question, maybe it would be better actually to make it, to think about it. Okay, if it's not that it's in the limits for the first and the limits for the second, if it's not that, then we continue to loop. Okay? So that would make it, I think, a little bit clearer yet. So here we have this loop going, okay, y dest. Oh, here we are. Because we continue to loop if it's not in both. If it's not in the first, if it's not in the limits with respect to x, and it's not in the limits with respect to y. If it's out of limits for one, we go back and pick both separately. We pick it again. Pick it again. I'm just picking them both at the same time. I guess you're saying, couldn't I loop with respect to each one separately? Yeah, I could loop with respect to each one. I'll just treat it like this for simplicity. We could go and you're right, we could loop on each one independently. We don't have to loop on them together. But it would take a little bit more code. Uh-huh. Oh. Yes. Yes. Okay, so if it's not in the first one, or if it's not in the second one, then this AND is going to fail, in which case it will loop back again, right? Am I missing something here? Again and again, as long as they're not legal. Unless both of them are legal candidate, it's going to go back and pick another one, pick another one, pick another one. Does that make sense? Yeah. This is certainly what was intended. I'm going to just check my is in limits. That's why it. This should be less than or equal to here, right? Not greater than or equal to. I suspected as much. And here we go. And, well, we can't see the pathology except with a large population. Let's go see if the pathology has been solved. Ready? That looks like a thing of more beauty. One that might warm a physicist's heart. So I think the reflection idea would also work nicely, actually. It would be, yeah. Okay. But somehow, ladies and gentlemen, this flipped classroom has become flipped again because I'm doing all the work here.